Welcome back, guys. It's Wednesday, your last video lesson of the week. So on Monday, we talked about what a system of equations was. So that just means we've got more than one equation grouped together. And we talked about how the solution to a system of equations is just the ordered pair that represents where the two functions are crossing on the coordinate plane. So it's an x and a y value that satisfy both equations. So yesterday we did a lot of practice with graphing to find the solutions. So we plotted and graphed by hand, and then we also graphed using Desmos. Today we're going to look at a method of solving these systems that requires no graphing at all. So you can solve these algebraically using a couple different methods. The method we're going to use today is called substitution. There's another one called elimination that we'll look at another time. But today, substitution. The definition of substitution in general terms just means a person or a thing that is acting or serving in place of another. So in math, we're going to use this, and we're saying this is a strategy for solving systems of equations that involves solving for one variable and using that solution to find another variable's solution. The reason we can do that is because if we know what one of them is equal to, we can substitute that value in for the variable in the other equation. So we're going to take a look at that. We have an example here that says that y is equal to x plus 3. It also says that y is equal to 3x minus 7. So the idea is, if y is already equal to x plus 3, why don't we just put the x plus 3 in place of the y right here? So let's look at what happens. If that's equal to y, let's just replace this y with those values. So this would become, that used to be the y equals 3x minus 7, but since y is equal to x plus 3, we're just going to replace it. We're going to substitute it. The reason we can do that is because they're equal. Why not? And the reason we want to do it is because now we've got an equation in terms of x. It only has one variable. There's nothing outside the parentheses, so I'm just going to get rid of it for a second and take a look at what you have. That's just an equation in terms of x, variable on both sides, but you guys know exactly how to solve that because we just did that in the previous unit. Let's solve it. We're going to draw our little squiggle. There's nothing to distribute, there's nothing to combine. So we're going to move our variables to the left using inverse operations. So we're going to subtract the 3x from both sides. It cancels on the right. On the left-hand side, we have 1x minus 3x's is negative 2x's. Rewrite everything else. Now I want to put our constants on the right. So I'm going to take this 3 and I'm going to move it over. We'll use inverse operations to do that. So negative 2x equals negative 10. We're just going to divide both sides by negative 2. I have x by itself. So x is equal to positive 5. It looks like we're done, but if you remember back yesterday and the previous day, we talked about how the solution of a system is an x and a y value because we need that location on the on the coordinate plane. So we need to take that 5 and we need to plug it back in. It does not matter which one we plug it into because it's going to work for both of them anyway. So just pick the one that looks the easiest. I think this one looks the easiest. So I'm going to put 5, I'm going to substitute it in place for the x. So this tells me that y is equal to 8. So my ordered pair, my x comma y, is 5 comma 8. If I wanted to check that solution, I would just need to plug in 5 for x and 8 for y. Make sure that it makes sense for both equations. You could also graph it. You can use Desmos or graph paper. You could plot these two lines and see that that's exactly where they're crossing. So this is just another method for solving a system, and it does not require a graph. This is all algebraic, and we are just inputting a value for y and solving the equation to get the x and y values. So the way we're going to practice this today is we are going to look at the same exact problems that we did yesterday, except yesterday we solved these by graphing. Today, since we already know the answers, we're going to solve them using substitution, and we're just going to check our answers based on what we did yesterday. So what I did is I solved the little riddle on the bottom of the page. That way we can reference that to check our answers at any point while we do this. The first 4 we're going to do together, and then numbers 5 through 12 are going to be your responsibility today. So let's start with number 1. I have my system of equations. Y is equal to 4x minus 8. Y is also equal to 2x minus 4. So what I want to do is I want to say, well, if y equals 4x minus 8, why not just replace the y in the other equation with its equivalent expression? Which means this equation now says in place of y, we're going to put its equivalent expression, it equals 2x minus 4. So right here, 4x minus 8. So now we're just going to solve. Draw our little squiggle. There's nothing to distribute, nothing to combine, so I'm going to move my variables to the left. I have 2x minus 8 equals negative 4. I'm going to move my constant to the right. So I'm going to add 8 to both sides. And finally, I'm going to divide by 2. So that gives me my x value, but I'm not done. I need the y value also. So I'm going to take that x value and I'm going to plug it back into whichever equation I like better. I'm going to go with the bottom one right here. So this means y equals 2 times my x value minus 4, which means I'm looking at 4 minus 4, so y is 0. So my ordered pair should be 2, 0. So I'm going to go over and look on my paper for 2, 0. The way I can check my work is down on the bottom. I'm going to look for number 1 and make sure the answer was I. So that means we did this one right. Okay, number 2. I have y equals and y equals. We're going to take all of this stuff that's equivalent to y, and we're just going to replace the y in the other equation with all of that stuff. So this used to be a y equals 4x plus 6. And inside of here, instead of putting the y, I'm going to put its equivalent, which is negative 3x minus 1. Now I just need to solve. So there's nothing to distribute, there's nothing to combine. I'm going to move my variables to the left. So I'm going to subtract them from both sides. Watch your signs here. I have negative 7x minus 1 equals 6. I'm going to add that 1 to the other side. And I'm going to divide by negative 7. All right, I've got an x value and I need the y value. So plug it in to whichever one you like. I'm going to go to the top one. So I have y equals negative 3 times negative 1 minus 1. I'm just going to evaluate this. I end up with y equals 2, which means my ordered pair is negative 1 and 2. So I'm going to look for that over here. Negative 1, positive 2 would be w. And if I want to check my work, on the bottom I'm going to look for number 2 and make sure it's a w. So we did that one right. Okay, number 3. Here's my 2 equations. Y is equal to 4x minus 12. So I'm going to replace the y in the other equation. So this is what used to be a y equals negative 3x plus 2. In place of that, we're going to put 4x minus 12. Separate it. There's nothing to distribute. There's nothing to combine. So I'm going to just move my variables to the left-hand side. I'm going to add them over. We're using inverse operations. This gives me 7x minus 12 equals positive 2. I'm going to move that constant to the other side. So I'm going to add the 12 to both sides. All right, now I just need to divide by 7. All right, so I have x equals 2, but now I need the y value. So I'm going to plug it into one of the 2 original equations. It does not matter which one, just whichever one you like the best. I'm going with the top one. So I'm going to have y equals 4 times 2 minus 12, or 8 minus 12. So I have that y is equal to negative 4, which gives me the ordered pair 2 and negative 4. So that's what I'm going to look at over here. 2 and negative 4 looks like L. I'm going to check my work. Number 3 down here has an L. We're doing good. Okay, we've got one more together and the rest are going to be on your own for today. So number 4, we are looking at y equals 2x plus 4. So what I want to do is put that in place of the y in the second equation. So this is now going to be what used to be a y equals 4x plus 6. I'm going to put all of that in its place. We're going to separate it. There's nothing to distribute. There's nothing to combine. So I'm going to move my variables to the left. We're going to subtract them. This is going to give me negative 2x plus 4 equals positive 6. I move my constant to the other side. So negative 2x equals positive 2, and we're going to divide both sides by negative 2. Okay, I have an x value, but I'm not done. We're going to plug it back into whichever equation you like the best. I'm going with the top one. And we're going to find the y value. All right, I got 4, which means my ordered pair is negative 1 and 4. That's what I'm going to look for on my paper. Uh-oh, bad news. Did I do my math wrong? I don't have a negative 1, 4 as an option. 4x plus 6, 2x plus 4. Let's see what happened. Negative 2x plus 4 equals 6. That's a 2. Negative 1. 2 times negative 1. Oh, negative 2 plus 4. Totally not 4, guys. Negative 2 plus 4 is 2. There we go. Good thing we have these multiple choice. So I'm looking for negative 1, positive 2. Let's see if that answer shows up on the bottom of the page. We're looking for number 4. Look at that. We got it. It's an E. Okay, so numbers 5 through 12 are your responsibility today. I will go ahead and do them. So you guys can either hit pause, try them on your own, and come back afterwards, or you can just watch me do them. Totally up to you. So if you'd like to hit pause at this point and do them by yourself, now's the time.